Students, this is the Digital Knowledge Irshad Academy with a fresh video of minimization of logic equations using K-map. As the name indicates, we are going to use K-map to minimize the logic equations so that the logic gates are minimized so as to reduce the cost of the logic circuits. We will look into four examples of K-maps. The first one is for variables A, B, C, D. Four combinations for A, B, 0, 0, 0, 1, 1, 1, 1, 0. Gray code values A bar, B bar, A bar, B, A, B, A, B bar. C, D, four combinations 0, 0, 0, 1, 1, 1, 1, 0. C bar, D bar, C bar, D, C, D, C, D bar. We have four minterms. These have been grouped together. One minterm, one minterm, one minterm, one minterm. Then they are grouped together. Let us now write the function. We are going to roll in a vertical. This column will share with this column, and we see that A is constant in vertical columns going from this column to this column. B is changing. We can write y function is equal to A. For the horizontal rows, see that D is constant from this column. From this column to this column, D is constant. We will write this. So for these four minterms, the function is A and D, means one AND gate. We are going to use one logic gate, that is AND gate. The logic circuit equivalent is four inputs A, B, C, D. A is taped from here to AND gate. D is taped from here, goes to the AND gate. Both inputs A and D. Output of the AND gate is A and D. We need one logic gate, that is AND. For the second example, it is AB, four combinations, CD, four combinations. Now we have four minterms, 1, 2, 3, 4. Let us group it together. We can make one large group. Beginning we said the group should be as large as possible, and at the same time the number of groups should be minimum. And we see that when we roll from left to right vertically, we see that B is changing. From here to here A is changing. From here to here B is changing. In vertical columns, A, B are continuously changing. But when we look horizontally, that is rows, we see that C bar, D bar is constant. Therefore, we will write y function is equal to C bar, D bar, means we need two inverters and one AND gate, that is the logic circuit. Four inputs A, B, C, D. C is taped from here going to inverter. The output of inverter is C bar. D input is taped here, goes to the inverter. The output of inverter is D bar, goes to AND gate. Output of the AND gate is C bar, D bar. Therefore, these four minterms, the circuit has been simplified, and we need two inverters and one gate. The output of AND gate goes to the next logic circuit. The third example is four minterms, they can be grouped when we roll or when we are going to fold it. This can make group with this. Now, when we roll vertically, we see from left to right, B bar is constant, B here, B bar is here, B bar is here. We can write function y is equal to B bar in the columns, vertical columns, but when we roll it from top to bottom or horizontal rows, we see that C bar, D bar, they are continuously changing from one row to the other row. We have only y is equal to B bar, means we need a single inverter, 4 inputs. This is the equivalent of logic gate A, B, C, D. The B input is tapped here, goes to the inverter. The output of inverter is B bar, goes to the logic circuit, means that 8 minterms K-map, the circuit has been minimized and we need only one inverter. The fourth example is, we have 8 minterms These are the 8 minterms. We are going to minimize the equations, make a group. This can be grouped together, a large group of 8, but number of groups should be minimum. When we fold it from left to right, we see that A, B, they are changing from one column to other, but when it is rolled from top to bottom, if we look into the horizontal rows, we see that C bar C, this is changing, but D is constant, D remains D here, the D is constant, therefore Y function is equal to D. This means we do not use any logic gate. Instead, the D input is directly going to the next logic circuit. The same, the 8 minterms, this can be minimized. One, two, three, four, five, 6, 7, 8. These are the 8 equations. 1, 2, 3, 4, 5, 6, 7, 8. These 8 minterms have been simplified by using K-map. Now we are going to use Boolean laws and Boolean algebra to simplify the 8 equations. The first minterm is, we look into this vertical A bar B bar, horizontal it is C bar D bar, it is A bar B bar C bar D. For the second minterm, look here in the vertical column, it is A bar B, A bar B, C bar D. For the third, it is, we look vertically, it is A B, but horizontal it is C bar D. Fourth minterm is A B bar, A B bar, C bar D. The fifth one, this is fifth one, we will look vertically A bar B bar, horizontally it is C D, C D. Sixth, A bar B, CD. 7th, it is A, B, C, D, A, B, C, D. 8th midterm, it is A, B bar, C, D. Now we have put the values of the variables. Now let us simplify it by applying Boolean laws. For the first two equations, we see that A bar, C bar, D, A bar, C bar, D, A bar, C bar, D is common. We have taken this common. Inside we write B bar plus B. We can apply inverse law or complement law. Says that when a variable is odd with its complement, it equals 1. And the identity law says when A bar, C bar, D bar, it is multiplied by the original variable, it results in original variable, that is A bar, C bar, D. Here we are applying complement law, here we are applying identity law. Let us solve these two. Again, we see that B bar is changing. We have, this is a complement law, and we now have A, C bar, D for this. For this combination, is B bar, complement law, and we virtually have A bar, C, D plus, for these two, B bar is complement law, the identity law. Finally, you have A, C, D. Now we have applied 4 complement laws, 4 complement laws, 4 identity laws, and from 8 equations we have reduced to 4 equations. Let us further simplify these two. See that A bar is changing. It is A bar here, it is a complement law, and the identity law, we have C bar, D for these 2 equations. For this, again, it is A bar changing, is a complement law, and then we have identity law, C, D. For these 4 equations, we have applied 2 complement laws and 2 identity laws. And from this, let us now further simplify this. D can be taken out, and we have inside C bar plus C. Again, complement law says that when a variable is odd with its complement, it results in 1. Identity law, when 1 is multiplied with the variable, it results in D. We have further applied 1 complement law and 1 identity law. See that these are the 14 times we have applied complement law and identity law, and virtually we got y function is equal to D. We have reached to the result by applying 14 Boolean laws, and then we concluded that we need no logic gate is needed, and we spent a lot of time and lot of calculations with 14 times applying Boolean laws. But in case of K-map these 8 minterms. Simply we make a group, and finally we got a result y is equal to d. Simplification with the K-map is easy and does not consume too much time. With conversely, Boolean simplification is complicated and cumbersome and needs a lot of time. That's all. In the next video we will solve 4 more examples. Thank you very much.